Okay, so in this video I'm going to have a look at deriving the area of a triangle formula for a right angle triangle only. So this is our right angle triangle here, and we have our base along here, so let's call it B, and we have our height here. It's a perpendicular height because this is a right angle here, so that our height of our triangle is just going to be this distance up along here. Now, if we have a look at this triangle, how are we going to work out the area of this triangle? Well, let's just take this line along here and project it up along here. So I'm just going to draw another line along here that's going to be parallel to this line and the same length as well. So let me just do that in a different color here. So just going to project it along here. Let's say looks like it's about that length. And then I'm going to take this length here, this side here, the hypotenuse, and I'm going to draw that down along here. Again, parallel to this line. So this line is parallel to this line. I'm going to draw another line parallel to this line here. So let's do that, the same color. So I'm going to draw that from here down to here. Okay, so what we've ended up with here is effectively a parallelogram. So this side here is going to be parallel to this, and it's also the same length. So it's also going to be length B. And this side here is parallel to this side here, also the same length. And we have a common side here, H. So let's have a look at our parallelogram here. Now we know that from a previous video, the area of a parallelogram is just simply length times height, or base times height. In our case, our length is our base. So our base, let's call it B times H. So the area rather of our parallelogram here is just going to be our base times our height. This length here times this length here. So this will give us the area of our entire parallelogram. The area of our triangle is what we want to derive. So what we know from this line here, which is a diagonal of our parallelogram, is that it bisects or cuts the area in half of our parallelogram. So in other words, this area here is going to be equal to this area here. So another way of looking at that actually is that this triangle here is actually congruent to this triangle here. It's the same size sides, same size angles, and hence the same area. The area of this triangle is going to be the same area as this triangle here. And we know that because this side is equal to this side here. This side here is going to be equal to in length to this side here, and this is a common length here. Okay, by the congruency side, 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 both triangles have equal sides. These two triangles are congruent, so we have congruent triangles. Therefore, the area of this triangle is going to be equal to the area of this triangle. Therefore, the area of our original triangle is just going to be half the area of the parallelogram. Now, the area of our parallelogram, I have that up here, the area of our parallelogram is base times height. So the area of our triangle then is just going to be equal to half times the base times the height. And that's our formula for the area of our right angle triangle in this case. In the next video, I'll have a look at the area of other triangles, non-right angle triangles.